Okay, so let's look at the semi-structural formula, how that's written. Okay, so we'll just do the examples that are in the book. We've got figure 916 on page 196. Same numbers, just rearranged. I'm sure that's a coincidence. And what we've got here is we've got these drawn out in sort of flat two-dimensional view, probably to make it a bit easier. So this business here, what we're interested in is first of all finding the longest carbon chain, which in this case we can see is this here. Okay, there we go. Now each of those carbons we need to describe what's going on at that carbon. So if we look at the first one, I'll do this one in blue. First carbon's here. So this carbon, apart from being attached to the other carbons, has 3 hydrogens attached to it. That's what's going on at the first carbon. Now the next carbon, which I can do in green, now this one here, is, well, what's happening with this one? It's got 2 hydrogens attached to it. We'll have a look at the next one. Use brown. This one here, this carbon, has 2 hydrogens attached to it. And finally, this carbon here, purple one, has 3 hydrogens attached to it. So this is another way of showing the structure. And if we understand that all of these carbons are joined together with at least single bonds between them, then from this we can get this structure as well. Now, another thing that we can do with this is we can see that this part here and this part here are exactly the same, and this only works when they're right next to each other. What I can do is I can join those two together and just say, well, I've got 2 of those. And so this can shorten even further to that, which is pretty neat. There we go. So let's have a look at the next example, the one next to it. Yep. Also with the chemical formula C4H10. If you were just given C4H10, by the way, C4H10 and C4H10, you would have no idea which of the compounds that's referring to. So more information needs to be given. Now, that can be given as a drawing, it can be given in this form here, or it can be the line drawing that I've showed you before. Anyway, we'll proceed. Now, if we know that this is the structure here, first thing we need to do is find the longest chain of 3 carbons, and that's either going to be this one here, or this one here, or possibly even this one here. All of those have 3 carbons in length. Now I'm going to make life easy for myself and just circle the straight one there. Just makes it easier on the eyes. There we go. And we will eventually, not right now, but eventually, like very soon, need to pick which end to start from, and we start from the end where there's more weight of functional groups. We'll worry about that later. For the moment, I'll tell you which end to start at. And because this extra group that's tacked on here is exactly in the middle, it doesn't matter if we start here or here. So I'm going to start at the left and work my way across. So let's have a look at this carbon here. This carbon, we're only writing about the carbons on the main chain here. So this carbon, what it's got attached to it, apart from the rest of the carbon chain, is these 3 hydrogens. So we can write this as CH3. Then we go to the next carbon, which I'll do in green. That's what I was using for the second one there. The second one, carbon, there. Now it's got a bit of stuff happening. We can see that it's got this hydrogen here, so we put that there, but it's also got this whole chunk here attached to it. So what we need to do is put CH3 there in brackets. Then we move on to the next carbon, which I was using brown for. Go for a bit of consistency. This one here, the last one on the chain, is C there, and it's got the 3 hydrogens next to it, CH3. Now, just like we did over here, when we've got 2 in a row that are the same, we can see that we've got these two, which are two in a row that are the same. So what we can do is we can write this as CH3, that's the first one there, CH, that's that bit there, and then CH3, 2. That's how they got that structure from the book. Another possibility, is that, and it's a little bit harder to read, is that if we look at this as the central carbon there, it's got a hydrogen attached to it, and it's also got 1, 2, 3 CH3s attached to it, which is how they got the first thing there. They've got it the other way around, actually. CH3, oops, 3, and then CH. Yeah, a little bit tricky, that one. This is perfectly fine here. This one makes more sense in terms of working from left to right through the drawing, so I suggest you go with that one there. Let's have a look at the one on page 197. Just gives a tick. So again, with this one here I'm doing now, which is 1, 2, 3, 4, 5, 6 carbons. It's C6H14. It's a structural isomer of hexane. It's not hexane. It's a hexane isomer. Okay. All right. So once again, when we're dealing with carbon chains, the first job that we've got is to find the longest possible chain in the molecule. Now we can see that we've got a couple of options here. 1, 2, 3, 4, 5. Nice and easily presented to you there. 1, 2, 3, 4, or 1, 2, 3, 4. So we're going to take the 5-length chain, which is this one here. And we're going to go through from the starting carbon through to the end carbon. Now, because this CH3 here is tacked on exactly in the middle of the chain, we can start at either end. I'm going to start at this end here, not this end here, because it just makes it easier going through from left to right, for me anyway. So let's go with the first carbon there. That carbon, apart from being attached to other carbons, has 3 hydrogens attached to it. That's fine. Then we go on to the next one here, which is this carbon only has 2 hydrogens attached to it. We go to the next carbon, this one, and we can see that it's got a hydrogen attached to it. And it's got 2 other things attached to it. It's got the rest of the chain here, and it's also got this bit. Now, we're going to do the rest of the chain separately. That's why we identified the chain in the first place. So we need to add this as an additional bit sticking onto this carbon here. Let's go on. We'll go on with the next one, which is CH2. And then finally, at the end, we've got this one here is a C with 3 H's attached to it. So that's the semi-structural formula there. Now that, we can't say that this and this, we can't do that business before where we do the CH2 stuff, because they're not right next to each other. They need to be next to each other for us to be able to do that, and they're not, so we can't group them. So this is in fact the final answer. Now, I'm going to do a couple here that I've just drawn up myself because all the ones that you've been shown in the book are symmetrical, and we need to have a look at ones that aren't symmetrical. Okay, this isomer of C5H12, a pentane isomer, there's a whole bunch of rules about this, but first thing we need to do is find the longest carbon chain. We can see it's sitting there. It's nice and easily shown just as the long chain there. They're not always drawn so simply, and in fact later on we'll have to go hunting for the longest chain. But right now we've got this 4 carbons here. That's fine, and we can see that this one here is attached to that. These 2 are both attached to that, so we may end up with a slightly anyway, I'll get on with that in a minute. Just gives a tick here. So What we need to do now is decide which end of the molecule to start at. That's what I was talking about. So we find the middle of the long carbon chain here. We put a dotted line down the middle, either on the paper or in your head. And you imagine that that's a tipping point, like a balance point, like a seesaw or a ruler balanced on your finger or something like that. And whichever end is heavier, in this case, this end is heavier than this one, that's the end that we start at. So, knowing that, we can see that this is going to be the end that we start at here. So now that we know that, we go this carbon first. It has 3 hydrogens attached to it. We move on to the next carbon. This one here has a hydrogen and a CH3 attached to it. The next one is a carbon, has 2 hydrogens attached to it, and then lastly this one has 3 hydrogens attached to it. Now, just like before, in the previous screen, you can see that this and this are exactly the same, so you might also read this as CH bracket CH3 2, meaning this is this one here, and these two are that one and that one, followed by the rest of the molecule. They are both correct. For my money though, I'd be going with this one, at least to start with, because it's much easier to reconstruct the molecule from this, and also this matches up neatly with the structure that is drawn here. There's no ambiguity. And one more for good measure. And lastly, we have a decane isomer. So let's get to work on this one. First job, find the longest carbon chain. So we can go 1, 2, 3, 4, 5, 6, 7. That's 7. 2, 3, 4, 5, 6, 7. That's another 7. 1, 2, 3, 4. That's no good. 1, 2, 3, 4, 5, 6. That's no good. 1, 2, 3. That's obviously not it. 1, 2, 3, 4, 5, 6. So 7's the winner. So we can either take this one here, this L-shaped one, or we can take the long flat one here. And I'm going to take the long flat one because it makes my life easier. So let's always do that if we can. Okay, now to figure out which end to start with, let's find the middle of this first, this straight chain here. So we can either count in pairs either end or just divide by 2 or whatever. It's not that hard to find the middle. We can see that the middle of that chain is right here. That's it there. So you can see easily that this side is weighted more than the other side, so we're going to start there. If the molecule was turned the other way around, then we could either draw it facing this way or just start the system, start the writing of the formula from that end, but it's always you've got to do it in order from the start of the chain on the left when you write the semi-structural formula. So let's do it this way. Okay, so first one, CH3. That's fine. Next one here is CH, and you can see that it's got a CH3 attached to it there. Then we go to the next one, which, this carbon here. Now it's got no H's attached to it, but it does have 2 of these. So we'll put CH3 in a bracket with 2. Then we will go on with, I'll use red. This one here, which has 2 of those. Then this one, which also has 2 of those. Then this one has 2 of those. And then this one, which has 3 of those. Now we can simplify this a little bit. We can go for CH3, CH3, that's fine. CH3, 2, what's he talking about? He hasn't simplified anything. And then quickly, CH2, 3, CH3. And I just put those 3 together there. That's it.